You take an onion out of the drawer. It's quiet, it's harmless, it's been sitting next to a potato all week. You put it on the cutting board. You bring the knife down and you cut it cleanly in half. Nothing happens for about 3 seconds. Then your eyes start to burn. Your nose runs. A single tear forms in the corner of one eye and then the other one, and within a minute, you are standing in your own kitchen weeping over a vegetable. You blink, you laugh at yourself, you keep chopping. What you have just done and what you are about to keep doing is set off a chemical defense system that an onion spent millions of years evolving for exactly this moment. The onion is not making you cry by accident. It is making you cry on purpose.
An onion cannot run. It cannot bite. It cannot grow thorns the way a rose can, or push out a poison the way a mushroom can. It is a soft underground bulb, full of sugar and water, sitting in dark soil, where rodents and insects and small grazers can dig it up and eat it. So it became a chemist. Chapter 1. The two chemicals that were never supposed to meet. Inside an intact onion, there is no lachrymatory chemical. None. If you put your face against an unbroken onion, nothing happens. There is no smell, no sting, no tears. The onion stores its weapon disassembled. In one part of every onion cell, there are sulfur-containing molecules called cysteine sulfoxides. Quiet, stable, harmless on their own. In a different compartment of the same cell, separated by a membrane, sits an enzyme called alliinase. As long as the cell is intact, the wall holds, and the two never touch. The onion goes about its life. The rodent walks past. Now imagine teeth coming down on it, or a knife. The instant the cell is crushed, the wall breaks. The sulfoxides spill into the alliinase. The reaction begins.
Within milliseconds, the enzyme starts producing sulfenic acids. These are reactive, unstable, and the building blocks of every smell and tear an onion is capable of generating. This part of the system was understood by the 1970s. There was just one problem. Sulfenic acids are not what makes you cry. Something else, downstream, was the real lacrimator. And for 30 years, nobody could find it. Chapter 2. The molecule built to make you cry. In 2002, a team of Japanese researchers led by Shinsuke Imai, working at the House Foods Company and in collaboration with academic chemists, published a paper in Nature. The title alone tells the story: an onion enzyme that makes the eyes water. They had found a second enzyme. The onion didn't just have one chemical reaction happening when you cut it, it had two in sequence. The first enzyme, alliinase, makes the sulfenic acid. The second enzyme, they called it lachrymatory factor synthase, LFS, takes that sulfenic acid and rearranges it into a single specific molecule. That molecule is called syn-propanethyl S-oxide. It is volatile, which means it floats. It is tiny, which means it travels fast. And the moment you cut into the bulb, an invisible cloud of it rises from the cutting board and drifts directly toward the warmest, wettest target in the room.
When syn-propanethyl S-oxide hits the surface of your eye, it dissolves into the thin film of water sitting there. That dissolution produces, among other things, a small amount of acid. The free nerve endings on your cornea, some of the most densely packed pain sensors in your entire body, register chemical irritation. Your brain interprets this as a threat. It triggers your tear ducts to flood the surface of the eye with as much fluid as possible to wash the attacker away. You are not having an allergic reaction. You are not being sentimental. Your eye is, in real time, defending itself against a chemical attack. The onion has accomplished from inside its own cells what almost no other plant on Earth has managed. It has reached out from the cutting board and physically wounded the thing eating it. Chapter 3. The War You Brought Home. here is the part of this story that is quietly astonishing. This system is not unique to onions. Garlic does a version of it, shallots do, leeks do, chives do. Every plant in the genus Allium uses some variation of the same trick. Separated chemicals, rupture-triggered enzymes, sulfur compounds that fight back. For most of evolutionary history, this strategy worked. Most animals that bite into an onion once learn very quickly not to do it again. Field mice avoid them, deer avoid them. Most herbivores walk a wide arc around an allium patch.
Almost every species this defense ever met, it deterred. It met one species, it did not deter. Somewhere around 6,000 years ago, in what is now Iran, a few humans tasted what was on the other side of the burn. They noticed that after the tears, after the sting, the bulb tasted good. They started planting it. Then garlic, then leeks, then shallots. We didn't outsmart the defense, we just decided we liked it. Today, there are over 100 million tons of Allium harvested every year. The molecule the onion built to make rodents flee is the molecule we tear up about while making dinner for someone we love. So the next time you cut an onion and your eyes start to burn, try to remember what is actually happening. A small living thing, pulled out of the dark, is doing the only thing it ever evolved to do when something started eating it. It is releasing a chemical it spent millions of years perfecting in a final, microscopic act of self-defense while you stand over it with a knife. Every kitchen on Earth runs on a quiet, ancient war between plant and animal. The onion never agreed to be food. We just decided we liked the fight. Wash the board, open a window, keep cooking. I'm Kyurio, a curious guy trying to solve the mysteries of everyday life, one video at a time. Subscribe my channel for more. See you soon.